Morena, tēnā koutou katoa. Welcome everybody. Welcome to our 14th webinar. And I'd just like to start firstly with a big thank you. Thank you to all of you attendees who have attended our webinars. And as we said earlier, for every participant that attends our webinars, we donate $10 to a chosen charity. And as of today, we've raised just under $15,000 since the start of lockdown for various charities. And today's charity is the Wakatipu Reforestation Fund, which is very close to Sian Taylor, our panelist's heart. She was lucky enough to nominate the charity today, so that's great. For those of you who don't know me, my name's Shane Clark. I'm the General Manager here at Nuralite, and I'm not going to speak to you about it, but luckily my panelists are going to talk to you today about the fundamental principles of passive house design. And luckily enough, I'm joined by Sian Taylor from Team Green Architects, who has obviously some experience in this field. That's why she's here. Lucky enough to be joining us from a very wonderful looking cafe down the Q-Town somewhere, lucky you. And also have Magical Mike Skilton, the National Sales Manager from Nuralite, who's also based down in the mainland. So this conversation may be one-sided, but we'll see how that goes. So that's what we're talking about today. As you should all be aware, hopefully, with the Zoom webinars, that we have a QA function. I do encourage you to be interactive and participate as much as possible. Otherwise, you'll just hear me talking all day and that won't be fun. Towards the end, we'll hopefully have a Q&A session to answer any of your questions. So feel free to populate that space down the bottom there in the chat function, and we'll go from there. And yeah, and I'll leave it over. We'll pass over to Sian, who's going to give us a bit of an overview of Team Green Architects to start with, who they are and what they do.
Sure. Thanks for that, Shane. Okay, so Team Green Architects is a practice that's owned by my partner Mark and myself, and we started the practice I think probably about 9 years ago, and it was as a result of me completing the Passive House course in Auckland with Cara, and as a result of that I felt there was no other real answer to creating buildings which could be warm and comfortable and low energy, and basically respond to the climate than passive house design. So that was the main reason for starting the practice, and it was a fundamental principle to what we do. So it's something that we incorporate in every single one of our designs, and it doesn't always mean that the passive house standard is reached, but essentially the whole philosophy behind passive house and the energy modeling, which is done through the passive house planning package, which is the software, is used for every single building. And what that essentially means is that you get to see how the building is going to perform relative to its climate, and that's probably the biggest thing that I like about it. It does create constraints around what you do, but the constraints are telling you how well that building is going to be behaving and how much energy it's going to be consuming. So one of the big things you're aiming for, and one of the big things it can give you, is comfort. So the biggest thing I guess I noticed when I first came to this area, which is now sort of 16 years ago, was how poorly the buildings were behaving, and how we were still reliant so much on plugging in heaters, hot water bottles, electric blankets, things which, me being from the UK, we just didn't have. And the buildings were still cold. So you go to the toilet at night and you're absolutely freezing, and it just didn't make any sense. And not only were the buildings far too cold, especially in our climate down here in the South Island, but in the summer we were overheating. There's too much moisture in the buildings. We've got massive issues in New Zealand with health problems because of the buildings that are produced. And it just all seemed to be done on the fly. There was no science behind the insulation or the construction of the buildings. It was just, if there was a cavity that was left by the framing that was required due to NZ 3604, then that was what you got in terms of insulation. There was nothing else to it. So one of the first things I remember trying to do at one of the practices I was working at was trying to ensure that the slab was thermally broken, because we're heating the slab and there's no requirement to insulate it. So you're heating the outside, and it just seems so crazy that that's what we were doing. So it was a big thing at the time. That was, you know, like I said, 15 years ago now, and trying to persuade the engineer that he had to put a break to insulate the slab. And obviously now we've got a lot better ways of doing that, but at the time it was a big thing. So passive house, just to explain what it is for those of you that don't know, there's some fundamental principles which are quite logical. So we've got the idea that we've got to highly insulate the building, and I think of it like a thermal blanket that you're wrapping up the building, and that does two things. It means that you are protecting the building from being too hot in the summer, but also obviously in the winter keeping the building warm. And the insulation is a combination of insulation in the walls and avoiding thermal bridging, but also high levels of glazing, which again, it's suitable to climate. So here in Queenstown, we have to use triple glazing, and the frames are obviously quite important, or very important, I should say, as well as the glass. So avoiding heat loss through windows is huge. It's the biggest source of heat loss in our buildings. In Auckland, or pretty much anywhere but Queenstown, or the central region that we're in, it's much easier to achieve the passive house standard because the climate is a lot more mild. We've got the extremes here in Queenstown. We've got extreme cold and we've got extreme hot. So it's this massive range that we've got to deal with. But the planning, passive house planning software, which is the energy modeling, gives you the ability to plug in the climate data relative to where you are, and then you alter that to suit where your building specifically is, and then that tells you how your building's going to operate, and you orientate the building, and you put in things like natural shading of mountains and trees and so on. You just see how your building behaves. So the other big thing with passive house is that you're creating an airtight building, and that's something which I think is still quite misunderstood in New Zealand. The idea of airtightness, I think, freaks people out. To explain, it's not completely airtight. It's a breathable membrane. So I try to explain it to people a bit like a Gore-Tex jacket, and you wouldn't go up on the mountain in just a woolly jumper. You'd be putting on a breathable windproof membrane, and essentially this makes one of the biggest differences at a relatively low cost is when you make the building airtight. And on top of that, then you put in the heat recovery ventilation, which is a super low energy then of maintaining fresh air throughout the building and doing it in a way that you're recovering the heat. So if the building is done to a good airtight standard, it can, and you've got a good ventilation system, it can retain up to 95% of the heat, and you're running on a really low energy, and you've just got a constant fresh air in your building. So our house, I don't know, Jade, if you want to go onto a picture of, I should maybe come back to that one. So this is where we're now living, and we moved our office here over lockdown because it's just such an awesome environment. Obviously we've got incredible scenery and place to live, but the internal environment is fantastic, and we don't have any moisture in the house. We're yet to put in an extract because it's a design element that we haven't quite finished yet. So that's since February. And
so is this the architect's own house that isn't finished yet, right?
Yeah, so anyone who's coming to our party on Saturday night will see a big hole where the extract, not in the thermal envelope, but a big place where the extract's supposed to be. But we don't have, and unless I'm completely immune to it, I don't ever feel like the building's smelling of food, and there's literally no moisture. It's just a pleasant environment day and night. We can go out at night, come home in the middle of winter, and never think about how do we heat this house? Like the house is just warm. In the summer, because of the overhang, our house is completely north facing, so the overhang here avoids overheating inside, and it's just beautiful all the time, and it's a lovely place to live. Jake, can I just go back to that previous, this one, actually, yeah, sorry, the one with the thermal bridging, that one, yeah. So this, just to quickly explain thermal bridging. So this is quite a good way of showing what thermal bridging is. You've got the blue-green areas, which is where insulation is on a typical building. And then you see what the timber studs do, which is a transfer of heat, because the stud is not as good an insulator, obviously, as insulation. And if that was steel, you'd be looking at red in that place. And you can see then what the windows are doing. Again, windows are typically the biggest source of heat loss through the building. So essentially your building is consistently losing the heat that you're putting into it, which is why it's never warm enough. You've got a lot of air that moves around because you've got air heating and then cooling. And it's impossible, especially in this climate, to actually heat your building because it just costs too much money if you're not doing something properly. So Mike, I don't know if you want to explain the product that's shown there.
Yeah, Mike, so just in this slide here, what do we, Sian's just touched on the fact that thermal bridging's a no-no, and it's something that one of the fundamental principles of Passive House they're trying to avoid. Do you just want to touch on what we're actually doing here in that picture on the left there?
So when we look at that picture, it's probably a traditional way that buildings have been constructed in New Zealand. When we look at the render on the left-hand side, this is more typical of what you'd find in North America and Europe. And ultimately, this is the concept that we're looking to bring more into play in the New Zealand construction industry. The insulation goes on the outside as opposed to in between the studs, and what that does is it allows the building to be more usable and provide insulation on the outside of the building that's going to give the best results in terms of the overall envelope performance.
Right, so it's obviously continuous across the face of the wall there, isn't it? Sort of eliminating that thermal bridging aspect we talked about.
Yeah, indeed. Yep.
Jade, could I go through to some of the details? Perhaps the detail. Oh, maybe I'll just touch on that graph first. But just this one I find really descriptive. Just to explain what the heating demand is when you start employing all of these things that we just talked about. So the higher levels of insulation, good windows, air tightness, and balanced heat exchange ventilation. So the taller one is any house that were built sort of pre 2007 when the code changed. And then you've got a house, which is number 4 here, which is anything that could be built now. And this is actually based on our house. So one that you just saw. So this would be what our house would be had it been built to building code in this area. So you've got a heating demand of almost 150 kilowatt hours per metre squared per annum, and that's with a north-facing site where we're capturing as much solar gain as we can, but you still see such a massive amount of heat demand. And then we drop down to here, which is what we call minimum, which is what we do as a practice as a minimum. We have a premium, but then you can see what happens when you come to Passive House. So you're pretty much, you're down to 15 or below for Passive House. So you've gone from 150 down to 15. So you're looking at essentially 10 times less heat demand for that building. And then if I go to the detail perhaps of our house, this one here, just very quickly to show some of the products that we use, which were through Nuralite. So we've got on the roof here, we've actually got a warm roof construction with the Enotherm, which is sitting on top of the plywood. And this is a sloping roof, but we're using a warm roof construction in a sloping roof scenario. we've got SIPS panels, and then the SIPS panel has to align with insulation, which is on the outside of the blockwork retaining wall, which is at the back for the lower level.
Mm-hmm.
And then we're using the Nuralite tanking all the way down the back of this, torch-on tanking all the way down the back of this blockwork wall, and then under the slab. And then on top of the slab for this house, we actually use the Enotherm again as our insulation, and then we have the timber flooring on top of that. So what you can see here is a continuous thermal blanket all the way around the building, and no real breaks in that thermal layer.
Yeah, that's great. So, I mean, if you were to take your red pen to the insulation layer, you could basically draw a complete line around the outside of the building, including below the ground.
Yeah.
Wow.
Yeah.
Sian, the one of the big challenges that you have as a designer is obviously the junctions, and being able to provide that continuous insulation and removing thermal breaks. So there's a lot of thought in terms of passive housing that goes into particularly those junctions.
Yeah, definitely. And minimizing complexity is a massive part of that. And that's probably one of the two big things that influences our design. Orientation is 100% key. If you've got a site that gives you the north facing orientation, then, you know, it's like you've been handed something on the plate. It's much easier. But if you haven't, you're always trying to maximize the gain in the way from what's free, essentially the sun. And avoid it when you don't want it. But then second to that, minimizing complexity, because the more that you spread out, you know, when you're cold, you don't open up your arms and, you know, out wide, you sort of hunker in. The more junctions and angles there are, like Mike said, the harder it is to insulate. We know with buildings in New Zealand, often you'll see multiple studs next to each other, and that's just the way it ends up coming from the framing manufacturer. It's super frustrating because it's where you've lost all that insulation, and then a corner essentially becomes almost impossible to insulate, and often gets covered up before there's any chance to put any insulation in there. So as Mike said, minimizing that is really important. I should go on to this because I'm really
No, you're going well for time. It's all right.
Okay. So yeah, Oliver's Ridge. This house has obviously got a lot of publicity, and it was huge for us. It came at the end of our first year in practice, and it was literally throwing down the gauntlet of everything we set out to do. Amazing client, and that's where you end up with great architecture. And they wanted a building that was low energy. They wanted comfort more than anything. They're Kiwis, but they're currently living in Brisbane, and they didn't want to be cold. But they wanted awesome architecture. And this is a building which is really quite large in scale. So we've got a big structure to achieve this roof here and this overhang. But we had to insulate that. So every single one of our roofs here is the Nuralite flat roof. And at the time, which is now sort of probably 6-7 years ago,
right,
it was one of the first projects for us where we were challenged like this and changed almost everything that we do in the way that we think about buildings. And Mike was part of that process. We had a much larger team because this is things we couldn't do by ourselves, and we relied on people like Mike and Nuralite to help us work out how this was going to work. And I know Mike had to go back to Europe to look at how the interstitial condensation was going to work, because we had to put all the insulation on top of the structure. Yeah, this is the detail here. This is the insulation on top of the structure, and then wrap it all the way around that edge, which is the parapet that is cantilevering out, and bring it right back to the building line. And essentially where you'd normally insulate, which is in this big cavity where this big steel is that we've also covered in insulation, that would be typically where you'd have your insulation, but we weren't doing that because it was the wrong place to have it. We had our air tighteners below the warm roof here, and we took the insulation all the way around and back, which was quite counterintuitive for us, but it was the way that it needed to be done. And the team was key to that. It's one of the reasons we called ourselves Team Team Green, and it's using the suppliers and the product manufacturers to help us work out what we've got to do for our region and our climate. Yeah, I think that's about it on this one. Yeah.
Really, that's a really good, I guess, run through on the I guess the fundamental principles of it, and even I got a good understanding out of that. So you've done well, Mike. I mean, we did a very small part on this project, I guess, and when you look at the overall project, we're just going to touch on the roof. Sorry, the Nuratherm warm roof system, and you give us a bit of a rundown on how that works and how it worked in this particular aspect.
Yeah, look, thanks, Shane. I'll come to that in a sec. But Sian talked on, just touch bases on a couple of really interesting things. One was poorly behaving buildings, and that's a byproduct of the material types that are traditionally used when we're looking at our construction methods. Our materials and systems are really based on science. This passive movement is based on science. It's proving to show that we can, build better, and that we've got the opportunity of contributing to that with better quality products. One of the reasons why Nuralite's been around in the market for over 54 years is because we partner with fantastic international building manufacturers, and we represent some of the largest names in the world: ICO, Rockwool, Pre-Proof, and Vitchathene, JM Membranes, and they all contribute their part to bringing these projects to life. And I think that's you've got a design concept and you've got a client expectations, but they're really hard to bring together if you don't have the products to work with. And at Nuralite, we're very fortunate that we have these outstanding manufacturers that contribute to this story. Right across the building envelopes that we were involved with in New Zealand. We moved our model a wee bit. We were traditionally, the waterproofers, the experts in flat roofing, waterproofing. And then as we've developed our business in the last 15 years, we've really pushed this warm roof, moving into warm walls, moving into warm tanking. And as Sian said, it's about providing that thermal blanket around the whole building. And that's really exciting for us. We love doing this because we just see it as contributing to making our buildings so much better with what we do. So, when I talk about our system suppliers, what do they do for us? We look at our certifications, fire performance, thermal performance, compression strength of the boards, wind uplift tests, zero condensation reports. When you're dealing with these types of projects, it's really important that you have the suite of products that go with the system. We see in a lot of cases where people try and, put blue with red and green, and then they hope that it will work. And we see a lot of this in the building industry. And it's becoming more and more important, it's becoming more prevalent that people are just bringing bits and pieces together to hope that they get a system. That's not the way that we work. We work around our systems-based approaches, on our warm roof systems, our tanking, and our outsolation projects. So all these things gives us the architects and the homeowners the confidence that they're going to get what they're investing in, and it's going to be a long-term solution for these projects.
Yeah, no, thanks for your very in-depth overview on what we do. It's quite enlightening. No, it was really good. And obviously, as Mike touched on there, actually just to talk to one of the questions that popped through, Mike talks about all these bits and pieces that makes up the system. Now, all those bits and pieces or components, if you like, in our case, they're actually all manufactured from the same manufacturer, which is a huge global manufacturer over in Europe. They actually make all the components. So if you wanted a Nuralite warm roof in Europe, you'd be getting exactly the same thing as you're getting here. It's not something that we've made up and put together, made in New Zealand, so to speak. Right, we are running very close to time. I've got a couple of questions that have come in from the floor. Now, one of the questions, I'm going to paraphrase your questions too, so excuse me. So with the passive house principles, are we limited to windows the size of portholes?
No, I mean, you can see, I guess, looking at this picture, right? But you know, this is not certified passive house, and you do have to look at that. But you plug all that information into the planning house software, and that really helps you with that, because you do essentially have to look at things like, for example, west glazing is the killer. You've got too much sun, especially in New Zealand, especially down here. We've got, you know, sun till 9-10 o'clock at night in the summer that is blooming hot, coming in through that west elevation, and that's when the sun is lower and it's coming right in, so it will overheat. So you do look at all of that, but essentially it comes back to orientation. So you're looking at still providing glass where, like this, what we're looking at here is the north elevation, so we want to capture sun through that elevation and have an overhang to stop the sun when it's much higher. But no, I think that's one of the key things we wanted to show with our company, is that architecture is not compromised by employing the principle that gives you a warm, comfortable, healthy building.
So the same sort of principles then apply. Just another question that's come in on a similar topic. I guess the same sort of principles apply to the use of actually opening doors and opening windows, etc.
Yeah. So basically, I mean, like I said, we're in our house now 24/7. The electricity bill at the moment is about $50 a month. And we basically, if it gets too hot, which it doesn't really get hot, but if it's a warm day, I just leave all the doors along the front of our elevation open. And it's like anything, you've got more airflow if you want it, but you don't have to. You're not reliant on that. You can, you know, if it's a cold day, obviously everything's closed.
Yeah, right. Another question here, I think this one might be for you, Mike, is do you do hydrothermic calculations?
Yes, we do. So we have a couple of, I think we do. So we have some programming that we do use. So we would gather the information, bring it back in, put it through our calculation models, and then have that discussion on the design concept. Okay,
cool. Another question I'm going to paraphrase. Sian, you talked about the passive house principles are specific to different sites around New Zealand. It's not simply a paint by numbers. And there's some questions here around the type of software, or there was a name of the software you use, or?
It's called P8. The shortening is PHPP, which is Passive House Planning Package. Can't remember what the PH. Sorry, Passive House Planning Package. And that's an extensive Excel spreadsheet, basically, that you plug all the climate data in and all the data about your building and shading, and it tells you what it needs, essentially.
Okay, great. When this webinar is fully recorded, this will actually go out with all the Q&A. So if we missed the spelling and pronunciation of different words and letters, it'll all be there in text for you. So another quick question, are you constrained to only using timber joinery?
No, you're not. Definitely not timber. And again, it depends where you are. Down here where we are, you're looking at needing a really good frame. So obviously there's other ways that you can do that, but and PVC is one, which is cheaper, but it comes with its own challenges with sustainability. Yep. But I believe, I haven't done a passive house in Auckland, but I believe you could probably get away with thermally broken aluminium joinery in Auckland.
Okay, great. All right, we're very conscious of your time, folks, and we do only ever want to take up half an hour of your time, which is generally the time it takes to enjoy a cup of coffee. So just while I wrap this up, we're going to flick out the second poll just to give us some feedback on the presentation today. So we can always polish our game, make sure we're on top of it. So while you're doing that, our next webinar, which is our last one for the year, will be a bit of a low-key walk through the Nuralite operations here and meeting a few of the individuals and basically showing you the premises and what we do and sort of I guess behind the scenes, I guess almost bloopers reel really. And the last poll will be basically, would you like a follow-up from today's presentation? So are you working on something specific at the moment? You'd like a follow-up from either the Nuralite team or the Team Green team? So if you pop your answers in there, one of us will be able to get back to you on that. So yeah, just a quick recap. Again, thank you all the participants. We believe we're doing some really good things here with some of the charities, and even just for attending, you've made the world a better place. So good on you. Today we covered off the fundamental principles of passive house design, which is basically wrap it tight and ventilate right, if I nutshell that. And like I say, if anyone wants to follow up, put it into the poll there. We'll be able to come back to you, and we'll be seeing you all next week with the last webinar. And just before I go, big thanks to the panelists, Mike, thank you, Sian, and big thanks to producer Jade behind the scenes. All right, we'll leave you with that. Thanks very much, guys. Bye-bye.
Yeah.